Hi grade 11s and welcome to this video. In this video, we will be working on the Mathematics Paper 1 for June 2023, and this is specifically from the Gauteng province. Okay, so the time allocated to this paper is 2 hours and we have 100 marks. Looking at the instructions, there are 6 questions and the diagrams are not necessarily drawn to scale, okay? Also, just remember that we are going to round off to 2 decimal places unless stated otherwise. Okay, with that being said, let's get into this video. Question 1, 1.1 says, if x is an element of 0, 1, 2, 3, 4, 5, determine the values of x for which this expression, the square root of 16 over 4 minus x, and 1.1.1 says, is not defined. Okay, so another word for this would be undefined. Okay, so for which values of x will this expression be not defined? Well, how do we know that an expression is or a number is undefined? That would be specifically if the denominator is equal to 0. Okay, so if the denominator is equal to 0, so a can be any number, and if the denominator is equal to 0, then it's undefined. So look at this, okay, the denominator here. Even if you square root it, okay, as long as that becomes 0, square root of 0 is still 0. So as long as this denominator becomes 0, it's undefined. So for which values of x will this denominator be equal to 0? So you see that if you want to solve for x here, you have to transpose the x. And so you just get x is equal to 4. And that will be our answer. It's where x is equal to 4. Okay, and it has to be that because they specifically just said not defined, okay? So undefined numbers are where the denominator is equal to 0. And non-real numbers would be when you square root or find the 4th root or the 6th root, as long as the roots, okay, you were using here was an even number, okay, and then you had a negative number, then this would be non-real. This is not the same thing as undefined. Undefined would mean there is no single number, okay, there's no particular number that can be used to define the value of this expression, okay, if the denominator is equal to 0. So there wouldn't be a single number to define that expression. But then non-real numbers just occur when you square root or 4th root a negative number. Okay, so we actually can define this. Okay, when you square root a negative number, we call that I, but we don't really work with that in high school so long. So that is our answer. Moving on to the next question. Question 1.1.2 says, so for which values of x is this a natural number? So what you can do is on your calculator, just put this expression down. Say 16 over 4 minus, and then substitute your values. If you see that you get a natural number, and remember what a natural number is. Natural numbers are basically like counting numbers, okay? When you count, naturally you start from 1, and then 2, and then 3, and 4, and so on, okay? So let's see. If we substitute 0, what do we get? 2. Okay, so x is equal to 0 works. We do get a natural number. Let's try 1. Okay, what do we get? A third. That's not a natural number. And then if we try 2, we get a third again. 3, we get a natural number, okay? 4 is a natural number, so 3 works. And then let's try 4. Of course, that wouldn't work. Okay, that's when the denominator is equal to 0. And then 5, you get a non-real number. So we know that the only ones that work are where x is equal to 0, where x is equal to 3. And that is our answer. Moving on to the next question. And then 1.1.3, this expression has to be an irrational number. Okay, so you saw that the ones with, well, the other ones just had surds. So we could still check again. We know it's definitely not 0 because that gives us a natural number. And natural numbers are rational numbers. Irrational numbers are your surds. So we're going to look for where we find surds. Okay, so 4 minus, and we have 1. And there we go, that's a third. So it works for 1. If you try 2, it also works. That's also a third. And if you try 4, you know it won't work. And 5, that gives you non-real. So it works for 1 and 2. So just tell them this is where x is equal to 1 or where x is equal to 2. And that is our answer. And moving on to the next question. Okay, question 1.2 says, solve for x, and 1.2.1 says we have 3x squared minus 4x. Notice how we have exactly two terms in this equation, okay? So do you see that terms are separated by plus or minus signs? Remember that. So between these two terms, what can we do to factorize this so that we can solve for x? We can take out a common factor. Do you see how in the first and the second term, we have x in common? So we take that out as a common factor. And then what are we left with? Well, we have 3x squared. And if you take x out, you're left with 3x. Okay, you can just say 3x squared divided by x, and then you see what's left. Same thing over here. If you said negative 4x divided by x, you're left with negative 4. Okay, is equal to 0. So now we have a value multiplied by another value, and they give us 0. The only way this is possible is if the first one is equal to 0, and then you said 0 times that, and then it gives you 0. Or if the second one is equal to 0, then you said this times 0, and then it gives you 0. So we'll say x is either equal to 0 or 3x minus 4 equals 0, and then just simplify. So this is equal to, we're going to transpose, it's 4. If you divide both hand sides by 3, x is finally equal to 4 over 3. And these are our answers. Moving on to the next question. Question 1.2.2 says we need to solve for x in this equation. Okay, straight away, do you see how the value with x squared is negative? So we might as well just bring it over to the left-hand side. So we have positive 6x squared, and then we have positive 3x minus 14, and now we say is equal to 0. Okay, so they don't really say correct to two decimal places or anything like that. You're just going to have to remember what the instructions say, because you see here, this is where we solve for x in the quadratic equation, and then this is probably the one where you have to use the quadratic formula, but you can still find out whether you have to or not, or just go ahead and use the quadratic formula. If you see certs, then you know that you definitely have to use that. Okay, so here is our quadratic formula, and you can see that this equation is now in the form of ax squared plus bx plus c is equal to 0. Okay, so the value of a, that's the value of b, and that is the value of c. So we'll just say x is equal to, and we have negative, and b is just 3, plus minus the square root of 3 all squared minus 4 times a, which is 6, and then times c, which is negative 14, and then all over 2a, so 2 times 6. And let's go ahead and substitute. So I'm going to start with the plus, and let's see what we get. Okay, so this is what we have. X is equal to, we can just round off to two decimal places since the instruction said we can round off to two decimal places. So that is going to be, that 7 is going to add a 1 to the 9, and then that adds to the 2. So it's just going to be 1.3. Okay, you can write it as 1.30, so it's two decimals. And then we have all x is equal to, and we'll change that to a minus. And now we get negative 1 point. Well, that 7 is going to round that up. That adds a 1 to the 7, so it becomes negative 1.8. You can call it 80 or just 8 like that. It's fine. Okay, since they just rounded up, I'm just going to leave them like that. Okay, moving on to the next question. Question 1.2.3 says we have this inequality and we need to solve for x. Okay, so do you see that one hand side is not equal to 0? Which means you just need to distribute here and get one hand side to be equal to 0. So let's FOIL out, and that's going to give us x squared. And if you say multiply in, then that's negative 3x, okay, plus x, and that would give us a negative 2x. And then lastly, the 1 times the negative 3 is negative 3. Now you can just go ahead and bring this over. So it becomes minus 12 is greater than 0. So x squared minus 2x, and that becomes negative 15 is greater than 0. So we can factorize now. Open up two brackets, still greater than 0. X times x gives us x squared. Now we need factors of negative 15. That would give us a negative 2. So with negative 15, one must be negative, one must be positive. So we can use 5 and 3. But then, to ensure that the 2 stays negative, we can give the negative to the 5 and the positive to the 3. So negative 5 plus 3 is negative 2. Okay, so that is minus 5, and I'll just put it as plus 3 and then minus 5. The plus first, because that's going to be the negative one. Okay, and now we need to find our critical values. we find our critical values like taking this and equating it to 0. If this was equal to 0, we would just say x is therefore equal to -3 or x is equal to 5. Okay, so these are our critical values. And now we can finally solve for x using your number line or your graph. So I'll just use the graph. You can see that at the point where we got one hand side equal to 0, we have a quadratic expression on the side. And if you graph that, it will create a parabola. Specifically, what type of parabola? Do you see the coefficient of x squared? There's an invisible one there. Okay, 1, it's a positive number, meaning you're going to have a concave up parabola, smiley face. And then we'll draw a line through the graph, okay, the x-axis, and we'll put down our value. So we have -3 over here and then 5 over here. Now, the inequality is specifically asking for the values of x for which this expression will always be greater than 0. So you see, when we substitute values of x in here, we are going to get an output. And that output is our y values. Okay, so if x was equal to -1, you say -1 all squared. The answer that you get here is your output, your y value. And the y values lie on the y-axis. So they're specifically asking for, where are your y values greater than 0? In other words, where are they positive? Okay, where are they greater than 0? And we know that we have positive y values all through here. Okay, so it means that the parts of the graph that will have positive y values would be every part of the graph that lies above the x-axis. Okay, so that's what we're looking for. And so less than 0 would be below the x-axis. Okay, let's go ahead and highlight all the parts that lie above the x-axis. That is all through here and here. And now we need to answer them in terms of x because we're trying to tell them the values of x for which this is true. So line these parts of the graph down to the x-axis so you can understand what exactly their x values are, these points x values. You can see that compared to -3, these are values that are going to the left-hand side of -3. So these are values that are less than -3. So we say x is less than -3. Or, and then over here, if you line this down to the x-axis, these are values that are going to the right-hand side of 5. So this is where x is greater than 5. And that is our answer. X is less than -3 or x is greater than 5. Moving on to the next question. Question 1.2.4, we have an equation with a surd and we need to solve for x. So the first step with equations with surds is you need to isolate the surd. So leave it on this hand side, okay? Leave it here as 2 minus x and then transpose the 2. So we have x minus 2. And now that the surd has been isolated, we can go ahead and get rid of that surd because this is what is stopping us from solving for x right now. Okay, so square this to get rid of it. But what you do on one side, you must do on the other side. Okay, so we square both hand sides of this equation. And so therefore that breaks open and we have 2 minus x is equal to, and this gets squared, so we get x squared. That gets squared, we get positive 4. Then first term times second term is negative 2x, and then you just double this, okay? You can still go through this whole method of x minus 2 times x minus 2, but that can take long, and so I try to avoid long steps because it's easier to make mistakes like that. So we have minus 4x in the middle, and now we can solve for x. Okay, you can see that the x squared is positive on the right-hand side, so take everything else over to the right-hand side. So we have 0 equals x squared, and if you have negative 4x and that comes over to become a plus x, we'll be left with negative 3x, and positive 4, and we have positive 2 comes over to become negative 2. That gives you positive 2. And now we can factorize. So 0 equals, open up 2 brackets, and then what times what gives you x squared? That's x times x. What times what gives you 2? Okay, that can give you negative 3 in the middle. So factors of 2 would be just 2 and 1. But you can see that the middle is negative. So the only way you could have gotten that is if both factors were negative. Okay, and we know that negative 2 minus 1 really is negative 3. Okay, so our factors are negative 2 and negative 1. And now we can solve for x. Okay, so something times something gives you 0. From the first question, you see that you equate the first bracket to 0. So if you say x minus 2 equals 0, transpose that negative 2 and you get positive 2. Or x is equal to positive 1. Okay, so these are our two solutions. But now we need to test to check whether they are actually valid. So take your original equation, 2 minus x plus 2 equals x, and check whether x is equal to 2 or x is equal to 1 is a valid solution for this. Okay, so for it to be valid, this equation needs to be true. This left-hand side must really be equal to the right-hand side when you substitute x. So let's substitute x. We get 2 here, and here we put 2. So square root of 2 minus 2, 2 minus 2 is 0, square root of 0 is 0, 0 plus 2 is 2. 2 really is equal to 2, so this one is valid. Let's check the 1. Okay, so if you substitute 1, what happens? We have 2 minus 1, which is 1. Square root of 1 is 1. 1 plus 2 is 3. 3 and 1 are not the same number. Okay, the left-hand side is not equal to the right-hand side, so x is actually not equal to 1, and x is actually equal to 2 only. Make sure you cancel the invalid and accept the valid. And that is our answer. Moving on to the next question. Question 1.2.5 says, if x minus 6 is equal to 0, you can see that this equation, okay, you can simplify it as x and then transpose this negative 6. It becomes positive 6. So what they're saying is if x is equal to 6 is one of the solutions of this equation that they have here, okay, determine one value of y for which this is equal to, okay, or really all of this is equal to 16. So what do they mean by if x is equal to 6 is one of the solutions? This has a lot to do with the way the previous question works. Do you see how this was not a solution to this equation that we had, okay, this initial equation, but this was a solution? When it is a solution, it means that it makes the left-hand side really equal to the right-hand side, meaning the equation is true when x is equal to 2. Okay, the square root of 2 minus x plus 2 really is equal to x if and only if x is equal to 2. So what they mean by is a solution is x is equal to 6 makes this equation true. Okay, the left-hand side really is equal to the right-hand side if x is equal to 6. Okay, so we need to determine a value of y for which this equation would be true. Do you notice something with the way this equation looks and the way that equation looks? Okay, they look very similar. They put it in the same order. Here we have x, okay, and here we have a 2y plus 3. And then it's plus 40 all over 2y plus 3 again, but here it's over x. So the 2y plus 3 stands for x here. And so if x is equal to 6 made this equation true, then just replace 2y plus 3 with x. That means 2y plus 3 is equal to 6 would make this equation true as well. Because in this equation, that x has been replaced with 2y plus 3. Okay, so 2y plus 3 is equal to 6. And so 2y is equal to 6 minus 3, which is 3. If you divide both hand sides of the equation by 2, y is therefore equal to 3 over 2. And that is our answer. Moving on to the next question. Question 1.3 says, solve for x and y simultaneously. Okay, so simultaneous equation. And do you see that we have a very simple looking equation first? Okay, we're always going to start with that equation. So you can see that in this equation, y can easily be made the subject. So we'll call this equation number 1, and we can call this equation number 2. And then using the first equation, because of how simple it looks, we're going to form equation number 3. So just leave y on the left-hand side, transpose this negative 1. So we'll have 2x plus 1. And this is equation number 3. So in order to solve for x, since this y is the subject here, you're going to take equation number 3 and you're going to substitute it into equation number 2, the equation we didn't even use yet. Okay, so this means that wherever you see y in this equation 2, just substitute 2x plus 1. Okay, replace it with that. So we have x squared plus xy. Okay, so multiply by y, meaning we multiply by 2x plus 1. And then minus 3x and then minus y. So replace that with 2x plus 1. But you see that 2x plus 1 has two terms. So if you're saying minus, you need to protect this with brackets. So that's 2x plus 1 and then plus 2 is equal to 0. And we are just solving for x in this equation. Okay, so this is x squared. If you multiply in, you get positive 2x squared, then plus x minus 3x minus 2x minus 1 plus 2 is equal to 0. Okay, now let's put our like terms together. These have x squared, they become 3x squared, and we're done with that. And then if you say x minus 3x, you get negative 2x, minus 2x, you get negative 4x. Okay, so that's minus 4x. And then negative 1 plus 2 is just positive 1 is equal to 0. Okay, so this is what we have, and we need to solve for x. Okay, so this is one of those trinomials where you can see that you have a coefficient of x squared that is not 1. So for this, you can use any method that you're comfortable with. I'm going to use the cross method here, just because of the kind of numbers they're using. They're using prime numbers here, okay? Okay, 1 is not a prime number, but, they don't have a lot of factors. So we have 3x squared, and we're going to think about what multiplied by what gives us 3x squared. And that is 3x times x. And then what multiplied by what gives you 1, and that's just 1 and 1. But do you see that only the middle is negative? So here's the thing about it. We said what times what gives us 1, right? The only way to get this positive 1 is by saying positive 1 multiplied by positive 1. Or you could have also said negative 1 multiplied by negative 1, okay? And we're going to have to think about whether these are going to be positive or negative. Well, we have a negative in the middle. There's no way we could have gotten a negative in the middle if everything was just positive. So clearly it's going to be negative 1 times negative 1 that gave you that positive 1. And here's why it's called the cross method. We are going to multiply across, and when you add the products that you get here, they should give you negative 4x, okay, the middle term. So 3x times negative 1 is negative 3x. X times negative 1 is negative x. And you see that negative x minus x really is equal to negative 4x. Okay, so these are our factors. Our factors are 3x minus 1 multiplied by x minus 1 is equal to 0. And now we can solve for x. Okay, so 3x minus 1 is either equal to 0 or x minus 1 equals 0. Here we'll say 3x is equal to positive 1. We transpose. Divide both hand sides of the equation by 3. X is equal to 1 over 3. And then here, x is equal to 1, okay, when you transpose. So we've solved for x, and now we need to solve for y. Looking at your equations, do you see that there's one equation that has y just nicely sitting as a subject? And that is equation number 3. It says y is equal to 2x plus 1. So we will say y equals 2x plus 1, and in place of x, we substitute these x values to find their corresponding y value. Okay, so 1 over 3, y equals, that's going to be 2 over 3 plus 1, which can be 3 over 3, which is 5 over 3. So 5 over 3, or y equals 2x plus 1. Okay, we substitute 1 here. So the y value that goes with this one is 3. Okay, so that's 3. So these are our answers. X is equal to 1 over 3 and y equals 5 over 3, or x equals 1 and y equals 3. And that is our answer. Moving on to the next question. Question 1.4 says, show that, okay, I was missing a t there, the equation x squared minus px minus p squared is equal to 2 has 2 real and unequal roots for all real values of p. Okay, so we need to show that this equation, right, is going to have 2 real and unequal roots. Okay, do not get so afraid with this 2 real, because of course, if there are unequal roots and there are 2 roots, this is a quadratic equation, as we can see. So if you have to graph it, it will create a parabola. Okay, and specifically a concave up parabola, a smiley face, because you can see the coefficient of x squared is 1, positive 1. So what they're just saying is, when we graph this and we look for the roots, the x-intercepts, you're going to notice that there would be 2 real and unequal roots. So we will have 2 completely different roots, okay? They're not going to be the same root. So 2 distinct roots, and they are also real. And they're not asking us to find the roots. They're just asking us to show that these are the type of roots we're going to get here. So we can find out the type of roots or the nature of roots using the discriminant. And this is where it comes from. Remember your quadratic formula? In this equation, okay, the quadratic formula, this is to help you find your roots. Okay, we're not going to try to find the roots. We're just going to try to figure out the type of roots we will have So we are focusing on the nature of our roots rather. Okay, so with this, look at this part in the quadratic formula, the b squared minus 4ac. There's something special about this part. This is the part that tells you the nature of your roots. And the reason it tells you the nature of your roots is because it is square rooted. When you square root a number, depending on what that number is, it will end up being a specific number. So here's the thing. For example, let's say this b squared minus 4ac, the discriminant or delta, if this was equal to 0. If you square root 0, you're just going to get 0. So all that would mean is you would have numbers here, number here, okay, a number here, a number here, and then you would have 0 being added or subtracted to this. So overall, let's say this was like negative 2 plus, and we had 0, okay, and then over, let's just say it was just 2. At the end of the day, you get negative 2 over 2, which is negative 1. This is a real number. It's also just one single root that you get. You get x is equal to negative 1. That is one root. So we see what happens when delta is equal to 0. You're only going to get one root. Well, with one root, the thing about one root is this would not be two roots, okay? It would just be one, meaning it doesn't satisfy what they're asking us for. One root really looks like this, okay? This is when the parabola only cuts the x-axis once. Then it will have one root. And what it looks like when you factorize that quadratic equation would be something like x plus 1 times x plus 1. You see that it's the exact same thing. So here, if you were solving for x, x would simply be equal to negative 1. Okay, so that's just an example of if delta was equal to 0. So now you see that for the roots to be unequal and actually have two roots, we can't have this be equal to 0. However, let's think about if it was greater than 0. If it was a value greater than 0, then you would actually have a number to add to this. Let's say this ended up being something like 5, for example. So you had something like negative 2 plus minus 5 all over 2. Okay, and let's just leave this as 3. Then in this case, you would have two separate roots because look at what we have. We say x is equal to, and we would say negative 3 plus 5 over 2. Or x is equal to negative 3 minus 5 over 2. Okay, there's plus minus here. And then you would have two different roots. So this specifically happens when the discriminant is greater than 0. This is where we will end up with two, okay, roots. Specifically two real roots. They're going to be real. Now, the only time you're not going to have real roots is when the discriminant is less than 0. Less than 0 means negative. If you square root a negative number, what happens? We saw this from question 1, the very first question, okay? If you square root a negative number, you get a non-real number. And then your root ends up being non-real. So for roots to be non-real, it simply means that parabola will just not intersect the x-axis, meaning you don't actually have roots on your graph, okay? No real roots. Okay, so that's an explanation. So you can see now that all they're asking us for is to show that this equation will have two real roots. How do we get two real roots? If the discriminant is greater than 0. What is the discriminant? B squared minus 4ac. So the question is to show that, okay? So we are not going to say b squared minus 4ac is greater than 0. No, then we would be already claiming that it's greater than 0. We are going to find b squared minus 4ac, and then we're going to show that this is actually a value that is greater than 0. Okay, so this is all we need. So we're going to find that discriminant. And to do that, you see that our equation needs a little more cleaning up. So we have x squared minus px minus p all squared is equal to 2. This needs to be in the standard form of a quadratic equation so that we can spot b, a, and c. So we'll rewrite this as x squared minus px minus p squared minus 2 is equal to 0. And now we can spot these. So it is in the form of ax squared plus bx plus c is equal to 0. Okay, so the coefficient of x squared, a, is whatever is in front of this, which is an invisible one. So we can see what a is there. What is the value of b? It's whatever is the coefficient of x, whatever is in front of x. Okay, you can see that it's just negative p here. That is b. And then what is c? C is whatever does not have x. And here, that will be everything here. Negative p squared minus 2, that is c. So let's go ahead and find this. Okay, so the discriminant is equal to, we say b squared, which is negative p all squared, minus 4 times a, which is 1, times c, which is just negative p squared, minus 2, and let's go ahead. So we are not trying to say it is greater than 0. We're going to just simplify it and then prove that the expression it gives us is actually a value that will always be positive, that will always be greater than 0 for every real value of p. Okay, so let's see. We'll say this is equal to, that becomes positive p squared. This is just I'll just go ahead and rewrite it first. Okay, negative p squared minus 2. Okay, so this is equal to p squared. And if you distribute in here, we get positive 4p squared and then positive 8. And simplify, we have 5p squared plus 8. So what are we doing with this? We are trying to show them that this discriminant that we just found is always going to be positive, okay? Is greater than 0. That will ensure that the roots are always going to be real and unequal, okay, for all real values of p. So can you prove that this expression will always be positive for every real value of p? Well, yes, we can clearly see it's always going to be positive. And here's the thing. Here's how we prove this. You're going to prove it basically piece by piece. So let's start with this part that we can see over here, p squared. You see that p squared? No matter what number you put here, this is always going to end up being positive or equal to 0. So we're saying that this is always greater than or equal to 0 for all real values of p. Okay, if you said negative 1 all squared, well, that gives you positive 1. If you say 0 all squared, that gives you 0. So it's always going to be greater than or equal to 0. Even if you took positive numbers and you square them, they still remain positive. Okay, so that's what we're claiming there. So we've proven that in that part. Now we're still trying to prove this for the entire expression. So we have 5. The next one is 5p squared. So what happens when you multiply 5, a positive number, to this? Well, if this was always going to be greater than or equal to 0, if you say times 5, let's say it was equal to 0. 0 times 5 is 0. Okay, and if it was a positive number, let's say it ended up being 1. Okay, 1 times 5 is 5. So this expression will always be greater than or equal to 0 as well. Okay, for all real values of p. And then lastly, now the entire expression. So we already know that 5p squared, that is always greater than or equal to 0. Then what happens when you add an 8 to it? This is always going to be greater than 0. Not necessarily equal to 0, because this part, the lowest that it can ever reach is 0. Okay, it can be greater than or equal to 0. Now if you add 8 to it, it's going to definitely be positive. Okay, so it can only ever be greater than 0 for all real values of p. And that is how you prove that this is always positive. And so you can finally conclude, therefore, that proves that this always has, or the equation, I don't want to rewrite it, the equation has 2 real and unequal roots for all real values of p. Okay, or the roots are real and unequal for all real values of p. And that is our answer. Moving on to the next question. Question 1.5 says, a farmer constructs a rectangular closure using 100 meter of fencing. Okay, so the shape that we're going to draw, it creates a rectangle and he uses 100 meter of fencing. This is going to be very important when you're thinking about a 2D shape. He uses one existing boundary wall as one side of the rectangular enclosure. Okay, so an existing wall. So one side in this rectangle would be missing. So look at the picture of what's going on. We have a wall. Okay, I'll just call this is the wall. And there's a rectangular enclosure. But then he's using this boundary wall as one side of that rectangular enclosure. So this rectangle is not made up of 4 sides, okay? Or, we can't like cut it into, we can't take that fence and then bend it so that it has 4 sides. We're only going to bend it so it has 3 sides, and then the wall is what is supporting that 4th side, okay? So the only sides we're looking at is this, and this. That's the rectangular enclosure. I've seen this question before in grade 12. Yeah, this was in grade 12. It's just solved. This type of question is going to be solved a little differently in grade 12 because there's calculus and you can actually use that. Okay, but this is what they say. We have calculate the dimensions. Okay, when they ask you for the dimensions, they're just asking in this shape, right? Because it's a rectangle, they will be referring to the breadth and the length. That is what they're asking for, okay? B and L, the dimensions. So calculate the dimensions of the rectangle to obtain the maximum enclosed area. Okay, emphasis on area. So we are going to be working with area in this problem. Okay, so I'm going to call the length and the breadth something else. Let's just call it x and y. So I'll call this x, I'll call this y. Okay, so we have x, y, I'll just call that x as well. Okay, so with this shape, what have they told us? Or really, what is the main goal? The goal is to find the dimensions. So find x and y specifically of the rectangle to obtain the maximum enclosed area. So what must x and y be so that the area of the shape is a maximum? Okay, so you get the highest area that you can ever get in the shape. The minute you start hearing things like maximum, okay, in grade 12, this topic is going to specifically be called maxima and minima problems. But here, when you start hearing maximum or minimum, it means that you're probably working with a curve, specifically a parabola. In grade 11, they would usually not introduce any other type of curve. They would just specifically work with a parabola. So this is the reason you can still solve this question in grade 11 because it's still a parabola. Okay, so we're going to focus on the area. And to find the area, we're going to say length times breadth normally, right? So L times B. But in this case, I've decided to call B X and, the length is Y. So we're just saying X multiplied by Y, and that would give us the area of the shape. So we need to solve for X and Y. That will ensure that this area is a maximum. Well, right now, looking at this equation, which is really what we're focused on, I can't really do that because we just have a is equal to x times y. And then what else do we do? So the only way we could actually find the maximum value of this is first, if it was a parabola. And second, if we knew one of these at least. Okay, we don't have to know the actual number that it's equal to, but we just need to find an expression in terms of x or y, okay, of any of these. So it could be of x, it could be of y, but we just need one of it. Now, you need to look into the question and see whether they actually gave you information to help you with that. So do you see that initially they said a farmer constructs a rectangular closure using 100 meters of fencing. Okay, so this is where we're going to see this. He uses 100 meters of fencing. Think about how that works. The fencing is going to be whatever he's going to put around the shape. So the wire that goes around the shape, of course, it won't be curved, it won't be curled, it will be stretched out. But then that fencing, okay, is a total of 100 meters. When you speak about the lining around a shape, what is another word for that? That would be perimeter. So what they've actually given us here is the perimeter of the shape. They've told us that the perimeter is 100. Now, you have to think about how perimeter is calculated. Normally in a rectangle, you simply say, okay, if I have a full rectangle, I say the length, and the breadth, and I say L plus B plus B, and then you just get 2L plus 2B. But in this case, we can't do that because there's a wall. You use the wall as one of the sides of this rectangle and then created this. So in this case, add what you have left. All we have is a breadth, a length, and a breadth. So we're going to add that. So we will say this perimeter was found by saying x plus x, which is 2x, plus y is equal to 100. And do you see now we have an equation? We can clearly make one thing here the subject and then substitute it into this so that we end up with an equation in terms of x or in terms of y. And then we can actually find the maximum area, okay, there. We won't actually find the maximum area because they didn't ask for that. They asked just for the dimensions for x and y. So we'll try to keep our focus on x and y, but we need to ensure that we can find the area of the shape in terms of x or y. Okay, so what can we easily make a subject here? We can easily make y the subject. So I'll say y is equal to 100 and we transpose that. So minus 2x. And so this is our equation. And we're going to take this equation. You see, it's like a simultaneous equation. This is like equation number 2, okay? Because this is like xy. And then this is equation number 1. So take equation number 1 and substitute it into equation number 2. So wherever you see y, replace it with 100 minus 2x. So we have a is equal to, and we have x multiplied by y. But y has 2 terms, so protected with brackets to multiply. So 100 minus 2x. Okay, so it is in terms of x. So I'm just going to go ahead and call this equation a of x. So I'm saying this is the area of this shape, okay, this rectangle that he's building, this enclosure, in terms of x. Okay, so depending on what x is. X for now stands for the breadth. Okay, so this is our area, and what we're just trying to find out is the dimensions for which this is going to be a maximum enclosed area. So for which it's going to be a maximum. If you look at this equation, right, a of x, the area of this shape, and you distribute, okay, so let's multiply that x in. If you do this, look at what we have, 100x and negative 2x squared. This is the equation of a what type of graph? Do you see the highest exponent is a 2? This is a parabola. So it means that the area of this shape, this enclosure, when we find the area, it can also be expressed as a parabola, right? And it's specifically what type of parabola? As you can see, the coefficient of x squared, the number in front of x squared, is a negative 2. So it ends up creating a sad face parabola or a concave down parabola. So with this parabola, what is going on is this parabola is a graphical representation of the area of the shape at different x values. What we're focused on finding is that maximum, okay? So the value of x and y, what should x and y for this to reach its highest area? If this is a graphical representation of the different areas that it reaches, then do you see where the maximum will occur? The maximum, the highest area it ever reaches would be right here. That's the highest y value we have. Okay, if we put down a y-axis, and I know it's going to look like this because I can't see any plus c. So this is where the y-intercept is actually equal to 0. So it's sitting like that. See, this graph has different areas at different places. Let's say when x is equal to, we'll specifically have to consider positive x value. So you should expect that the x value you get here must be positive. So let's say when x is equal to 1, for example, the area of this fencing, okay, whatever that shape is, okay, I don't know what he's building, but that area would be whatever this y value is. Okay, at x is equal to, for example, here, let's say this was 3. That area would be equal to this. And what we're trying to find is what exactly should be the x value, okay, where the area is at the highest it can ever be. Okay, and then we'll find the y value as well. And so from that, you see that all we're trying to do is find out the x value of the turning point of this. Okay, how do you find the x value of a turning point of a parabola? You find this x value by saying x is equal to negative b over 2a. So this is the only step that differentiates the way this would maybe be done in grade 12 and grade 11. In grade 11, you simply just use this. In grade 12, you could use calculus to find this. Okay, still the same thing. So x is equal to, and we will say negative b. Do you see b is always the coefficient of x? So that is 100, negative 100 all over 2a. So 2 multiplied by a, which is negative 2. And so x is simply equal to, that is 100 over 4, which is 25. Okay, so we know what x is. Remember, focus on the goal. They said calculate the dimensions. They didn't say find that maximum area. Now, if I take 25 and I substitute it into this, okay, if I substitute it into this equation, I'm not finding the other value. I'm not finding the length. I found the breadth so long. I know now it's 25, right? And this is in meters, so 25 meters. If I substitute this into this, I'm not going to find the length. What I'm going to find is the area, the maximum area of the shape. They didn't ask for the maximum area. They only asked for the dimensions, so x and y. So how do you find y if you have x? Well, go to an equation where you saw y was equal to, and that was in equation number 1, okay? So y equals 100 minus 2x, and so we'll just say y is equal to 100 minus 2, and then x is 25, and let's find this. 25 times 2 is 50, so this is 100 minus 50, which is 50. Okay, so x equals 25 meters and y equals 50 meters. These are our values. The length is 50 meters. The breadth is 25 meters of this enclosure. And that is it for question 1. Question 2, 2.1 says, simplify without the use of a calculator, and 2.1.1, we have been given an exponential expression. Okay, so with this exponential expression, do you notice what is common all through? We've got 3, and in 9 we also have a 3, and in 27 there's also a 3. All of these numbers can be written with a base of 3. So we're going to rewrite this as, this is still 3 to the power of n plus 2. And then this is, 9 can be written as 3 squared, but then you still have the n plus 1 outside, so raise to the power of n plus 1. All over 27 can be written as 3 to the power of 3, and then all raised to the power of n minus 1. And let's go ahead and simplify this. So this is equal to 3 raised to the power of n plus 2 multiplied by, now you see here your exponents are going to multiply. If you're saying this entire base is raised to the power of exponents, the exponents will multiply. But you have 2 terms here and 1 term here, so the 2 is going to multiply to the n and the positive 1. So it becomes 3 to the power of 2n plus 2, and then all over, and we have 3 to the power of 3n minus 3. Okay, in the numerator, you see that we are multiplying with the same base, so we are going to add the exponents. Okay, if the bases are the same and you're multiplying, you're simply just going to add the exponents. So keep the base the same. It's 3 raised to the power of n plus 2. Let's just add straight away. So n plus 2n is 3n, and then 2 plus 2 is 4. So 4. All over, and we have 3 to the power of 3n minus 3 is equal to, and now we are dividing by the same base. When you're dividing and you have the same base, we are going to subtract the exponents. So just be a bit careful with this one, because if we have 3 to the power of, and we still have 3n plus 4, if you are subtracting by this, you need to use brackets because you're subtracting by something that has more than one term. So we open brackets and we have 3n minus 3, or you could have just seen this as this, minus the 3n, minus the negative 3, okay? So it would multiply in, and that becomes a negative 3n, and this will become a positive 3. Okay, so this is 3 raised to the power of 3n, and negative 3n would cancel, and you have 4 plus 3, which is 7. And this is our answer. You can write 3 to the power of 7 out, okay, using your calculator, but they did say without the use of a calculator. So this is probably where they want you to stop. And that is your answer. Moving on to the next question. Question 2.1.2 says we are given this, and we need to find the value of this expression if x is equal to 1 plus root 3. Okay, so just rewrite the expression, but in place of x, substitute 1 plus root 3. So that is, there's x squared, so we'll say 1 plus root 3. So just say this is equal to 1 plus the square root of 3 all squared. And then this goes all over 1 plus, and there's x, so 1 plus square root 3. Okay, let's simplify. So you see with surds, 1 and root 3, we can't just like add them together and then, they don't become square root 3. So you treat these roots as if it's a variable. If you had 1 plus x all squared, how would you simplify this? You'd probably say 1 plus x times 1 plus x, and then you'd FOIL out. Or you could use that quick method where you square the first term and so on. So that's what I'm going to do here. Square the first term, I get 1. Square the last term, if you say root 3 all squared, that radical will break open and you're left with a positive 3. Then we say first term times second term, okay? And now that gives us root 3. And then you double this, so multiply by 2. So root 3 times 2 is 2 root 3. Okay, so that's what we have in the numerator. You can see how these are numbers so they can add. So this goes all over. You have 1 plus 1, which is 2, and then plus square root 3. Okay, let's add the numerator. 1 plus 3 is 4. So 4 plus 2 root 3. Do you notice something about that numerator and denominator? They look very similar. But you see that in the numerator, you have a common factor of 2 in those two terms that we see there. So we can take 2 out as a common factor, and what are we left with? In this first term, if you say 4 divided by 2, you're left with 2. And in the second term, if you say 2 square root 3 divided by 2, those 2's will cancel and you're left with square root 3. So positive root 3 all over 2 plus square root 3. And now you can see that we are multiplying here, so we are allowed to cancel with whatever is common in the numerator and denominator. So these cancel and our final answer is 2. So the value of that expression is 2. Moving on to the next question. Question 2.1.3 says we have to simplify this expression if A is not equal to B. Okay, so before jumping into this, let's just see what we have. So you can see that we have this whole difference of 2 squares thing going on here. We can factorize using difference of 2 squares, but we need a good reason to do that. Let's see. This is 5 over 2, okay, the exponent here. So it means that it has just been written as a base with a rational exponent. It used to be a third. So if you wanted to put it back as a third, it would be a plus b, and then the inside exponent over the outside exponent, okay? So the inside exponent would have been the 5, and then this is a 2, so it's a square root. Why would we need to even change this? Is it necessary to change it? It actually is, and here's the reason why. You see, you're multiplying by this. So if your bases are the same, okay, and you're multiplying, then you would add the exponents. You would definitely have something with the same base here, because this is an a squared minus b squared. If you use difference of 2 squares to factorize this, you'd get a, and then you can say minus b squared or minus b, and plus b. Okay, so with this, the a plus b, because it's still, under the radical, and they are multiplying, you can see that they can actually multiply. These two would work together. If you have a square root of a value times the square root of another value, you are allowed to write it under the same radical. So you would write it as the square root of x times y. Okay, so because these, will definitely be able to multiply, we would write this as a big square root and it will multiply across. So yes, it actually is necessary to change that. Always just look at it and then decide, instead of just trying to work something out and, you don't want to end up getting stuck. So think about it first. Okay, so we have this is equal to, and I'm going to rewrite that now as a minus b and a plus b. Okay, and it's multiplying to this, and let's just rewrite that in third form. So that is the square root of, we have a plus b all raised to the power of 5. Okay, and then this goes over, might as well also put that there. So there's probably a common factor situation. So the square root of a minus b, and then it's all raised to the power of 1, which is just a minus b, so it's fine. Okay, because inside exponent over outside, so the in is 1. Okay, so this is what we have, and now we're just going to multiply those. You can see what would multiply, okay, or what would come together, because their bases are the same. So we have, this is equal to, they will be written under one single radical, and we still have the a minus b. But then when these two multiply, you see they have the same base. If you have the same base and you're multiplying, what do you do to the exponents? You add the exponents. So this would be x to the power of 6. In the same way, a plus b times a plus b raised to the power of 5 is actually a plus b raised to the power of 6, because the exponents get added. That invisible one here with a 6. Okay, so this is what we have. And then all over the square root of a minus b. And let's see, what can we do here? Okay, we can square root this, because you see its exponent is a 6. To square root, you always say that inside exponent over the outside exponent. And here's why we can square root now, because you see that what we have under the radical, they are multiplying. So you are allowed to square root in this case. If you had the square root of 4 times 2, you can square root this. Okay, square root of 4 and square root of 2, which would give you 2. And then if you square root the 2, it doesn't square root, so it stays root 2. But if you had 4 plus 2, then you can't square root this, because you cannot square root across plus signs. Okay, it doesn't work like that. Okay, so this is what we have, and we can square root that. So inside exponent over outside exponent, that is the 6 divided by 2, which is 3. So this simply just becomes a plus b raised to the power of 3. And then we say square root, and we have a minus b. Okay, just a minus b here. And then in the denominator, we also have square root a minus b. Great. Okay, so they would simply cancel, and all we are trying to find the value of is a plus b raised to the power of 3. It would be helpful to find a short way to simplify this, just like we, simplified this kind of thing. We can simply just say first term squared and second term squared. There's also a short way to do this, but I'm just going to deal with it step by step. It's fine. Okay, so a plus b all to the power of 3. You can rewrite this first as a plus b multiplied by a plus b all squared, something we're more familiar with. And so this is equal to, we have a plus b multiplied by, and this would become square the first term, a squared, square the last term, b squared, and it doesn't have to be that far, plus b squared. First term times second term is ab, and then double this, so multiply by 2, which gives you positive 2ab. Okay, because we're not using the short method of doing this, let's just be very careful. So we're multiplying a binomial by a trinomial, 2 terms by 3 terms. So we're going to multiply first term with every term in here. And so that is going to be a to the power of 3, and then it's plus 2a squared b, and then that's plus ab squared. And then we're done with that. And then second term times all terms in here. And that is plus a squared. I need to forget this is a squared. Okay, this is a squared b plus 2ab squared, and then plus b to the power of 3. And then just put your like terms together. So we have a to the power of 3. And what is like with 2a squared b? That would be a squared b. And so together, okay, 2 plus 1 is 3. So this is 3a squared b. And then what is like with ab squared? That would be the 2ab squared. So that is a 3ab squared, and then just plus b to the power of 3. And that is our answer. Okay, and that is it for this question. Moving on to the next question. Question 2.2 says, prove that 2 over x plus the square root of 2 minus 8 over root 8 is equal to negative 2. So we need to show that this actually ends up giving us negative 2. Okay, let's rewrite this. So this is equal to, let's simplify. The only thing to simplify right now would be with this. Okay, the square root of 8 can be rewritten as a simplified third. So this is 2 over, we have 1 plus square root 2 minus, and we say 8 over, if you have the square root of 8, you can rewrite this as 4 times 2, okay? Because 4 is a square number, and so we can square root that. So this is equal to 2 over, and we have 1 plus square root 2 minus, and we have 8. Now if you square root 4, you get 2. But if you square root 2, you still get the square root of 2. Okay, so in this expression, can we simplify further anywhere? Yes, okay, the 8 and the 2 can divide. So when they divide, we have 2 over, and we have 1 plus square root 2, and 8 divided by 2 is negative 4, so because we still have the minus there, and then all over square root 2. Okay, so we are subtracting fractions. When fractions are being subtracted, you need to ensure that the denominators are the same. So this is a 1 plus root 2, and that's a root 2. What do you have to multiply to each denominator to ensure that they're exactly the same? You cannot get the root 2 to say this, okay? So you can't say times 1 times positive 1. That's not going to work. This is an 1 plus root 2. If you say 1 times root 2, it says root 2. It's not going to work like that. So we can just say, okay, let's look at what the common denominator should be. Because we can't really get this to look like that or this to look like that, we're going to simply take their denominators and multiply them, and that would be the common denominator. So it's the square root of 2 multiplied by 1 plus the square root of 2. Okay, and now in the numerator, look at how we look at this. Focus on the denominator, right? you see that in order to make the denominators the same, you must have said something multiplied by the denominator and the numerator. So look at this denominator. We got it to say 1 plus root 2. What did you multiply this by to get it to look like this? You multiply by root 2. So what you do on the bottom, you must do on the top. So this is 2 multiplied by root 2, which is 2 square root 2. Okay, and then same thing over here. Our denominator is root 2, but then it needs to get to this point. So what did you multiply to this denominator to get it to look like this? You must have multiplied by 1 plus square root 2. So we would say minus 4 multiplied by 1 plus square root 2. And now we're just simplifying. So this is equal to, we have 2 square root 2 and then distribute. So minus 4, and then that becomes minus 4 square root 2. Okay, so you see with surds, if you see that your surds are the same, it works like variables, like terms. Here, if we distribute, we just have square root 2 and then plus, okay, root 2 times root 2 is really just root 2 squared. And so that radical breaks and you get a positive 2. Okay, in the numerator, we have like terms, root 2 and root 2. So if you say 2 root 2 minus 4 root 2, 2 minus 4 is negative 2. So this is negative 2 square root 2. I'll just rewrite it in the correct order. Number first. So negative 4. And then that becomes minus 2 square root 2. And then this, I'm just going to rewrite this as 2 plus square root 2. Okay, so just similar to the question that we had, it was in question 2.1.2. You see that there's a common factor here. Okay, these look very similar. See, you have the root 2 and the root 2, and you've got 2, which we know there's a common factor of 2 in 4, right? So we can just take out a common factor. If all of these are positive, then we're just going to take out a common factor of what is common in the first term and the second term. That is negative 2. Okay, don't take out positive because then what's in the bracket will be negative. So negative 2 comes out, and what are you left with in the first term? Negative 4 divided by negative 2 is positive 2. What are you left with in this term? Negative 2 root 2 divided by negative 2 is positive square root 2. And there we go. So you see that the denominator and the numerator are the same. They would simplify. They cancel too. They cancel and become 1. And so you just have minus 2. And there we go. We have proven this. We have shown them that this expression really is equal to negative 2. Moving on to the next question. Question 2.3 says, given isosceles triangle JKL with JK being 2 plus root 3 and then LK being 4. Calculate the area of triangle JKL correct to 1 decimal place. Okay, so they say this triangle is an isosceles triangle. So, okay, they didn't really specify which lines are equal, but it seems like they mean these two. If it's isosceles like that, then it means that we have two congruent triangles here. Okay, so if this is an isosceles triangle, look at what we have. We have a case of congruency because here you've got this triangle over here, and this side is already equal to this side. So that's one side equal. And then they share a common side of JM, and this is 90 degrees. So this is 90 degrees as well. So you've got a side, and an angle. So that means that they are congruent. So they are the exact same triangle. So for you to find the area of the entire shape, we can just use a half times the base times the height. So half times the base times the perpendicular height. You can already see that the perpendicular height would be JM and the base is 4. So all we have to do is we need to find JM. Okay, we can use Pythagoras to find JM, but to use Pythagoras, we could be using this, and we would need MK. So MK, if this is an isosceles triangle, then because this side is exactly the same, it's congruent, okay? These two triangles are congruent. It would mean that LM is actually equal to MK. So I'll start with that. Because they said it's an isosceles triangle, LM is equal to MK, and we know that MK is therefore equal to, so half of 4. So that's 2, that's 2. So that's 2. Okay, 2 units each. Great. Now that we know what MK is, we can use Pythagoras to find JM. So JM, squared is equal to, it's a shorter side, so take the longest side squared, jk squared, minus the other shorter side, mk squared. So that's jm squared equals, and we're just going to say jk is 2 plus root 3 all squared minus mk, which is 2 all squared. Okay, so jm squared equals, and when you square this, square the first term, it's 4, square the last term, root 3 all squared becomes positive 3. First term times second term is 2 root 3, but then double that. So it becomes 4 root 3. And then negative, and then 2 squared is 4, so minus 4. Okay, jm squared equals, put your constants together, that gives us 7. Okay, those cancel, 4 and 4 are gone. So we just have 4 root 3 plus 3, and we find the square root of this. Okay, so square root both hand sides. You don't have to consider negatives. We're working with lengths. So jm equals, and you can't square root, you see, we can't square root anything here because there's a plus in the middle. So this is just square root 4 square root 3 plus 3. But that is just jm. That's the perpendicular height. And now to find the area of this full triangle, we would say, so the area of triangle JKL would be found by saying a half multiplied by that base. The base is the entire base of this triangle, which is 4 units, multiplied by the perpendicular height. And that is the height which we just found to be all of this. So multiply by the square root of 4 root 3 plus 3. So I guess that's the only challenge there, like multiplying those. It's probably not a challenge because they said correct to 1 decimal place, so you can use a calculator at this point. Okay, so that's just going to multiply to be, you can just use a calculator, it's fine. They did say correct to 1 decimal place. And that is, so 1 decimal place, so just 6 point, and you just let the 0 decide. Okay, 0 is less than 5, so it's just going to round down. So 6.3 units squared. So, and there we go, that's our area. So 6.3 square units, and that is it for question 2. Question 3, 3.1 says, the first 3 terms of a linear sequence are x, and we have 4x plus 5, and 10x minus 5. So this is a linear sequence. Determine the numerical value of x. Okay, so what do we know about a linear sequence? Well, a linear sequence has a common or constant difference. So whatever you add from x to get to this is exactly the same as what you add from this to get to that next term. Okay, and to find that common difference, we simply say term 3 minus term 2, and also term 2 minus term 1. So 10x minus 5 minus, and we say 4x plus 5. And to find, again, that same constant difference, we say 4x plus 5 and then minus x. But the thing is, they both represent the value of that constant difference or the common difference. So they are exactly the same. And so we will equate these to show that. And that would help us to solve for x. Okay, so this is our equation. Let's solve. We say 4x minus x, which gives us 3x. And then plus 5 is equal to, and let's simplify the side. So this is 10x minus 5 minus 4x minus 5. When you subtract there, you're going to get, so this is still 3x plus 5 equals, that is 6x, and negative 5 minus 5 is negative 10. Okay, now we can transpose. So I'll leave 6x here, take the 3x over, and we have here that comes over to become positive 10, so 5 plus 10. And so that gives us 3x, this gives us 15. Divide both hand sides of the equation by 3, and finally, x is equal to 5, and that is our answer. Moving on to the next question. Question 3.2 says, consider the linear sequence, and they give us this sequence. Determine n if the nth term is given as this. Okay, so initially it sounds like they're asking for the nth term, but clearly they're not, because they're saying if the nth term is given as this. So they've already given us the nth term, and we need to find the value of n, okay, if the nth term is this. So this n, remember that n stands for the term number. So for example, this is term 1, this is term 2, this is term 3. Okay, if they're asking for determine n, which didn't really seem like they were asking for that, but yes, that seems like what they're actually asking for. When they say determine n, they just mean what exactly is, which term belongs to this last term that we have here. I feel like they could have been a little more clear on that. Okay, but n would really just mean how many terms do we have in this sequence. Okay, so we're trying to find out what exactly is n here. So we know this is term 2, this is term 3, this is term what? Okay, so in place of tn, you're going to substitute negative 106. So we have tn, say tn is equal to negative 106, and this is our tn formula. We have negative 3n plus 20 is equal to negative 106. This is just a linear equation, so you can easily solve. So negative 3n equals, and if you transpose that, that's going to become negative 20, so it's negative 126. Then divide both hand sides of the equation by negative 3, and finally n is equal to, and we'll just get our answer. Okay, so 120 divided by 3 is 40, and then 6 divided by 3 is 2, so this is 42. And that is our answer. So there are exactly 42 terms in this sequence, and term number 42 is equal to negative 106. Moving on to the next question. Question 3.2.2 says, which term is the first negative term in the sequence? Okay, just remember how terms work, okay? So negative term just means the value of it is negative. So these are the term values, okay? We can also call the term values, a general way to call the term values is by saying Tn, because this expression represents each term value at different term numbers, okay? So at different values of n. So what they're asking is which term is the first negative term in the sequence? So these are term values, okay? Which one would be the first one that would be negative? So where is Tn less than 0? And then we're going to look at the answers it gives us, and we're going to specifically look for the first n value that will be negative. But you need to remember how n values work, because these are patterns. Your term numbers, okay, your n values, so term 1, term 2, those are only going to be natural numbers. Just remember that. So we will just go ahead and look at that. So where's Tn less than 0? Okay, where are our term values less than 0 or negative? So this is, okay, our Tn formula is this, negative 3n plus 20. So negative 3n plus 20 is less than 0. And all we have to do is solve for this inequality. Okay, it is linear, so it's very simple to solve for. Just transpose that 20. Negative 3n is less than negative 20. Then divide both hand sides by negative 3. But you see, we are dividing by a negative. When multiplying or dividing by a negative value, the sign will change. So it's no longer less than, it's now greater than. So we have here, n is greater than, and that's just going to be 20 over 3. But we will need the decimal form of that so that we can just see what exactly that is. 20 over 3, okay, it's 6.6 recurring. And so now we can actually just analyze this. You see, it's saying that n is greater than 6.6 recurring, right? So our solutions lie where the values of n are greater than this number. That's where we're going to get negative term values, okay? So the first term, if we're looking at this, values that are greater than 6.6 recurring, what is the first natural number? Because term numbers can only be natural numbers. What is the first natural number that would be greater than 6.6 recurring? The first natural number immediately greater than this number would be 7. Okay, so it means what they're asking for is that first negative term will be the 7th term. This is where n is equal to 7. So it is the 7th term, and that is our answer. Moving on to the next question. Question 3.2.3 says, determine the value of the 20th odd term in the sequence. So the 20th odd term. Okay, for that, we would need to know what the sequence looks like and get, how the odd and even numbers look and where they really just show up. So we have 17, 14, 11. Let's just keep that down. Okay, so there are two ways of really doing this. You can sort this out in two ways. You can think it through in two ways. So we could separate these term values into two different patterns. Okay, so just look at what happens here. The first term is odd, the second one is even, and then the third one is odd. And so the next one would be even. And we can also just see the constant difference. You see, from 17 to 14, you must have said minus 3 and then minus 3. So this would be 8 and so on. So this is what we have. And we need to find the 20th odd term. So what you could do is focus on the odd terms, right? And then just start a new pattern with that. 17, 11. So think about it. If from 17 to 14, you said 17 minus 3, and then from 14 to 11, you said minus 3, then from 17 all the way to 11, you must have said minus 6. And so the constant difference in this new odd pattern would be negative 6. I think this would be the easiest way to do this. The other way, it will still work, but it just takes a little more thinking. So we will just create a new pattern. So this is 17 minus 6 gives you 11, and then 11 minus 6, and then we'll keep going like that. Okay, so let's say we just had this, and we can see now that the difference is 6. We would just have to find the formula of this pattern. And so since we're trying to find the 20th odd term, just find term number 20 in your odd patterns. And that would be the 20th odd term. Okay, specifically odd. I think this would be the best way to work on it because they didn't really try to confuse you with that, Okay, so this is what we're going to do. Just find the 20th term in this odd pattern, term number 20. So we need to find a new formula, and just depending on the rule that you use, it may be, more simple or not. I'll just go ahead and use Tn equals dn plus c because this is the method you learned in grade 10, and maybe you'll still be using it at this point. But in grade 12, that formula for a linear sequence is simply Tn equals a plus n minus 1 times d, okay? But this is what we have here, and so we'll say Tn equals, and our difference is 6, so 6n plus c. Okay, so that difference, remember the difference is negative 6. I don't know why I said 6. And now we can finally just find the nth term of this. So this is Tn equals, and we can use this way, dn plus c. So in place of d, we say negative 6. Now to find the value of c, just substitute any one of the terms in here. I can go for term 1. I know that term 1 is equal to 17. But you see now that in place of n, I've substituted 1. So I'm going to do the same here. Substitute 1 and then plus c. And then term 1 is actually 17. So we say 17 equals negative 6 plus c. Transpose, and we're going to get 23 when you add. And then this is equal to c. So our general term is currently Tn equals negative 6n plus 23. And all we are trying to find here is to find out what exactly is the 20th term. Term number 20. So because this is our odd pattern, so the pattern with only odd numbers. Okay, so we could just say term number 20 equals a negative 6 times 20 plus 23. And so term 20 is equal to, and we'll get our answer. Okay, and that is negative 97. And that is it for this question. Moving on to the next question. Question 3.3 says, consider the pattern, and we have 3 and A and 10 and B and 21. And they say the pattern has a second constant difference of 1. So this means this is not a linear pattern. This is a quadratic pattern because it has a second constant difference. And they want us to use this information to determine the values of A and B. Okay, so second constant difference of 1. How do you find the second constant difference? By finding the first difference. Okay, so let's find the first difference. We say A minus 3. That's the first term in your first difference. And then, I feel like I don't need all of these though. But okay, let's just see. Then we have 10 minus A. And then here we're just going to have B minus 10. It's always next term minus previous term. B minus 10. And that's 21 minus B. Okay, so these are the first terms. I just feel like I need this though. Okay, so now that we have that, they told us the second constant difference is 1. So we know that already. We know that if we take this minus this, it gives us 1. You see how that's going to create an equation? you know that if you say 10 minus a minus this, okay, which is an a minus 3, so I need to use brackets because we're subtracting. I know that if I do that, I'm going to actually find a difference of 1 because they're saying the second constant difference is 1, okay? So this equation will help to solve for a, and that's all we would need. We just need a, and then we can find b with that. Okay, so all through. So let's find a, that's 10 minus a, and then multiply in negative a, that becomes a plus 3, is equal to 1. Okay, variable on one side, numbers on one side. So this is negative 2a, and then 10 plus 3 is 13. If you take it over, it becomes negative 13. So you have 1 minus 13, which is negative 12. Then divide both hand sides of this equation by negative 2. Therefore, a is equal to 6. Okay, so we know what a is now. A is 6. What is the value of b? Well, we can just use the same procedure to find b. Since we have a, and we know what the second constant difference is. So pick one that is going to have b in it. If we use this, it would still work though, because you're just trying to find b and you know what the constant difference is. So there's just many ways of dealing with this. You could say b minus 10 minus 10 minus a, okay, is equal to 1. We know the second constant difference is 1. You could have also done this and said that that is equal to 1. So just take the one that would look easier. I think subtracting these two would be easier. We'd say 21 minus b minus b minus 10 is equal to 1. And you just solve for b. So 21 minus b, that becomes plus 10 is equal to 1. B is on one side, that is negative 2b is equal to 21 plus 10 is 31. If you transpose it, becomes negative 31. So that's 1 minus 31, which is negative 30. Divide both hand sides of the equation by negative 2. B is finally equal to positive 15. So you see the ways we could have found that. A is 6, B is 15, and we are done. And that is it for question 3. Question 4 says, the diagram shows the graph of f of x is equal to ax squared plus bx plus c, which we can see is a concave up parabola with the following essential properties. So a is the turning point, and it's 2 and y, okay? B, and then we have c, and these are x-intercepts of f. And then we have another point on this graph, which is 6 and 7, so point D. The first question says, write down the coordinates of B. Okay, so B is the other x-intercept. So notice what we have on this graph. We have 2 x-intercepts, well, we have one, and then this one is missing. But we also have the x value of the turning point of the parabola. So if we draw a line through this line is our axis of symmetry. So what the graph does on this side, it does the exact same thing on this side. So from this point, if we go exactly 3 units to the left, as we can see it is 3 units to the left, we would have to move to get to this point. That would mean that to get to the next x-intercept, you would also go 3 units, but this time it's 3 units to the right. And then we'll get to that. Because this is the axis of symmetry, what the graph does on this side. It does the exact same thing on this side. Okay, so we know this is 2, and then to get to B, you're just going to add 3. Okay, because we can see it's a difference of 3 from 2 to negative 1. So the coordinates of B, the x coordinate first, will be found by saying 2 plus 3, which is equal to 5. And so B as a coordinate is simply 5 and 0, and that is our answer. And I'll just make sure to put it down. This is 5 and 0. Moving on to the next question. Question 4.2 says, show that the equation of f can be written as this. Okay, so we've already found the value of b, and so because of this, we can go ahead and find this. You see now that we have 3 points and just one incomplete one. To be honest, you don't even need this to find what they're asking you for. If you have to find the equation of this function, depending on how you find it, you could still find the full equation. So you see how you've been given the turning point? If you use the parabola's turning point form, then you could easily find this. But we can just go ahead and use this method. I guess I'll just do both methods so you can see what I mean by this. So there are 2 methods that you could use. You could look at the parabola in turning point form. And so that is y equals a multiplied by x minus p all squared plus q. And the values of P and Q, those are the coordinates of your turning point. But you see that here, our turning point is not complete. We only have the X value. So we have the value of P, and we don't have the value of Q. We can just leave that as Q. So we'll substitute that first, and we have Y equals A multiplied by X minus 2, because that's P, all squared, and then plus Q. So in this equation, all that is missing is the value of Q and the value of A. So that means that you only need 2 points, or at least 2 pieces of information to find this. So to find this, we already have 2 points, okay? Other than this, we have 2 complete points. If we weren't even looking at this point, we would have this point, and we could just substitute them. So we would just substitute those, that's C and D. Okay, so in place of Y here, we say 0. We say 0 equals A multiplied by, and X is -1, then minus 2 all squared plus Q. Okay, and simplify. So -1 minus 2 is -3. All squared is 9. So that's going to be times A, which is 9A. So if you have 9A here plus Q, you can just make Q the subject. So transpose -9A is equal to Q. And that would be our first equation. And then substitute this point. So we have 7 equals A multiplied by 6 minus 2 all squared plus Q. And this is 7 equals, and we're going to have 4. So 4 squared is 16, that's 16A plus Q. And then just transpose that 16A. So this is 7 minus 16A is equal to Q. Then we can simply solve for A here by equating Q. So Q equals Q. And so we have -9A is equal to 7 minus 16A. And then transpose this 16. So that's positive 16A minus 9A. And we have 7A equals 7. Divide both hand sides by 7. Therefore, A equals 1. Okay, and then to find Q, just use the easier equation of Q. So that's Q equals -9 times 1. And so Q equals -9. Then, if you take this and you put it back into this equation that was almost complete, that just needed the value of A and Q, and then you simplify that, you will get it in standard form. Okay, so in place of A, we just say this is 1, and then this is -9. So this would just be Y is equal to 1 times anything stays the same. So X squared, and then plus 4, then they multiply, and then you double them. So it's minus 4X, and then -9. Okay, so 4 minus 9 is -5. And there we go. You see, so it looks like that, as you can see. And then we could also have worked through this, looking at the kind of points that we were given. We have x-intercepts, okay, and then we have another point. So what we could have used is the x-intercept or the roots form. So that would be y equals, and we say a multiplied by x minus the first root, okay, x1, and then x minus x2. And then we would just substitute that. So a, and then we put down our x1 and x2. So that's -1 and 5. So x minus -1 give you a +1, and then x minus 5. And now you see that in this equation, all that is missing is the value of a. So to find a, just substitute a value in place of x and y, and that would solve for a. So here we would just simply take this point D, which is 6 and 7, and we substitute, which is over here. So y is 7 is equal to a times 6 plus 1, and 6 minus 5, and this gives us, so we have 7 equals 6 plus 1 is 7, 6 minus 5 is 1, so times 1 just stays 7, times 7 gives you 7a. So we have 7a equals 7, divide both hand sides by 7, and you see the whole thing with this now. We have a, take a and substitute it back into that equation, distribute and put it in standard form, and you'd have the exact same equation. Okay, like that. But you can see that this method would be shorter. So if you ever see that you were given x-intercepts, rather use this shorter method. Okay, so just you can ensure that it is written as f of x, like they said it should. And that is our answer. Moving on to the next question. Question 4.3 says, determine the equation of a line, which is h of x, passing through point C. So this line passes through C and is perpendicular to the line passing through point B and the y-intercept of f. Okay, so we have a straight line, right? But this line is perpendicular to the line which passes through point B and the y-intercept of f. Okay, so you see with this, all that's going on is we have the y-intercept over here. We have this line. So this is not the line we're finding the equation of. The line we're finding the equation of is perpendicular to this line, but it passes through C. Okay, so something like that. Okay, they are perpendicular. So in this, you see that to find the gradient of this line, because this is not grade 12, okay, if it was grade 12, there's a way to just quickly find the gradient of this line. With this, you first have to find the gradient by using this line. You know that this line passes through the y-intercept and b. So if you can find the gradient of this line, you find the gradient of the line that you're actually looking for. Okay, so it passes the y-intercept. What is the y-intercept? Well, we have the equation of f in standard form, and you can see that the y-intercept c, okay, is -5. So this is -5, and as a coordinate, it's 0 and -5, of course. So we'll just take that and find the gradient of that line first, and it will help us with the gradient of the line we're actually looking for. Okay, so to find the gradient of a line, we simply say y2 minus y1 all over x2 minus x1. So this is equal to y2, I'll just start with the top. So this is -5 minus 0 over 0 minus 5. So they both stay negative. That's -5, -5, and that gives us +1. So the gradient is 1. So if the gradient of this line is 1, then what is the gradient of the line we are looking for if they are perpendicular? Perpendicular lines, here's what we know about their gradients. If two lines are perpendicular, then it means that when you multiply them, the gradients will give you -1. This gradient is already 1. So the gradient of the line we are looking for would be equal to -1. Okay, 1 times -1 gives you -1. It's -1. And we know the gradient of the line we're looking for now, but they also tell us that the line passes through point C. Okay, so just take point C and we would find the full equation. So it's -1 and 0. And now we can find the equation of the line. You can use y equals mx plus c, or we can just use this. Y minus y1 equals gradient multiplied by x minus x1. And so this is going to be, this is x1, that's y1. So y minus 0 equals our gradient of -1, and then times x minus -1, which becomes a +1. So y minus 0 is just y, is equal to, and this multiplies into become -x and -1. Okay, and they told us it's the equation of h of x, and they didn't say, write it as y equals, so I'll just rewrite this as h of x is equal to, and that is our answer. Moving on to the next question. Question 4.4 says, for which values of x will x multiplied by f of x be greater than or equal to 0? Okay, so when we find x values and you multiply them by the y values of f, they should give us a value greater than or equal to 0. The ways that we can get values greater than or equal to 0 is if, well, first of all, if either one of them are equal to 0. If this is equal to 0 and it multiplies by an f of x value, okay, y value, it will still give us 0. Okay, likewise, if f of x was equal to 0 and multiplies by an x value, it will still give us 0. So keep that in mind. And so we have positive. If we said positive multiplied by a positive, it will give us a positive, a value greater than 0. Okay, also if we said negative multiplied by a negative, it would give us a positive, a value greater than 0. So we need to look for places where x is positive. Okay, so the x values are positive, and at the same time the y values are positive. Or the x values are negative and then the y values are negative. Okay, let's see if we find this. Okay, it is the last question, so I just got rid of those lines, and let's see. Let's start with the x, because that's actually the easier part. We're looking for where we have positive x values. So where do we see positive x values? On the x-axis, your positive x values are all through here. This is where x is positive. Now, for these x values, we need to find where the graph of f has y values that are also positive. Let's just look at the y values we have. Look at the y values all through here. These are positive y values, because if you take all these points and you map them to the y-axis, it gives you a positive value. Okay, look at this point over here. It's 6 and +7. So the x values should be positive, and so should the y values. So this would be all through here. Wherever the graph is above the x-axis, this is where it has positive y values. Once we go below here, then you see now that the graph has negative y values. That's not what they want. They want positive x values and positive y values. So it works all through here. And so if you line this down to the x-axis, you can see where this is going. These are values that are simply greater than 5. Okay, so we know that now. This is where x is greater than, but then we also need to consider, you see that at 5, the graph of f has a y value of 0. So if you take this x value, we're just taking the x value times the y value. See this x value, okay, of 5 multiplied by the y value of 0, they give you 0. That's one of the requirements. It needs to be greater than or equal to 0. Okay, so x is greater than or equal to 5. That works. And then let's go ahead and see if we see the second scenario. So where are the x values negative? And then for those same x values, the y values of f need to be negative. So the x values are negative all through here. Now we need to ensure that the y values are also negative. So we're looking for negative x values and negative y values. Okay, so which part of the graph, which piece of the graph exists in this quadrant where x is negative and the y is negative? You can see that is here, okay, over there. So if you line this to the x-axis to understand for which values of x this exists, do you see that it starts here at -1, right? And it's values that are greater than -1, but then they don't go past 0. So, but less than 0. You also have to consider the actual values that you have here. So at -1, if you take this point -1 and 0, the x value is -1, and remember we're multiplying x and y values, so multiply by the corresponding y value there, that is 0, and that will give you 0. Okay, so it's one of the requirements. It needs to be greater than or equal to 0, so that works. And here on the y-intercept, this is where x is equal to 0. Okay, you can see that this is the cutoff point. After this, we no longer have that scenario anymore. Here we have where the graph is negative, but unfortunately the x values are positive, okay, all through there. So at this point as well, that would also be an included value at x is equal to 0, because you see, the x value is 0. If you multiply by the y value of -5, you also get 0. So this is where x is greater than or equal to -1, but less than or equal to 0. And so these are our two solutions. We can just go ahead and put them down. Okay, and these are our answers. And that is it for question 4. Question 5 says, given g of x is equal to, and we have 6 over x plus 2 minus 1, and p of x is equal to 6 over x minus 3 plus 2, 5.1 says, sketch the graph of g showing clearly the asymptotes and the intercepts with the axes. Okay, so we're sketching the graph of g, and it's a hyperbola. So there's some steps that we need to just remember. So with the hyperbola, we can consider first the shape. Okay, so the shape of this graph, you're going to find the shape by looking at the value of a. Remember that the hyperbola is in the form of y equals a over x minus p plus q. So the value of a is a value that is clearly positive, greater than 0. And so what this means is that your graph is going to lie in the first and the third quadrant. Okay, so that's the shape. And then secondly, we need to look for the asymptotes. So with the asymptotes, we have two asymptotes, a vertical and a horizontal. The vertical one, remember how vertical lines, okay, they only pass one particular x value. They have multiple y values. Okay, this has a y value over here, a y value over there. So vertical asymptotes, you can just remember that they start with x is equal to. Okay, so the vertical asymptote would be x is equal to, and it's like taking this and equating it to 0. Okay, it's really because it's that value of p. It's that x value that will not have a y value because it will become undefined. Okay, so the graph will never pass that line. So we have, you can say x plus 2 equals 0 and then transpose x is equal to -2. Okay, you could have also rewritten this as in this format so you can see the value of p, which is the value of your vertical asymptote, okay, that x value. So that would have been x minus, and what would you subtract by to get back to +2? You would subtract by -2. Okay, so there you can see x is actually equal to -2. Okay, so that is the vertical asymptote. And then the horizontal asymptote, that is a horizontal line. Okay, so horizontal lines have one particular y value, but then multiple x values. So they start with y equals. So y is equal to, and it would be the value of q. Okay, so whatever q is. And that is just -1. So y is equal to -1. Okay, so that is our horizontal asymptote. And then we can go ahead and find the intercepts. So the intercepts with the axes, that will be our x and y intercept. Let's see. So to find the x-intercept, you simply make y equal to 0. So we will say 6 over, we have x plus 2 minus 1. Now in place of g of x, which stands for y, we're going to substitute 0. So this is 0 equals, and let's solve for x. So you can take this over and it becomes positive 1 is equal to 6 over x plus 2. And then we can go ahead and just multiply, cross multiply really. That's fine. So put this over 1 and cross multiply. So 6 times 1 is just 6. And anything times 1 stays exactly the same. Transpose the 2 and you have x is equal to 6 minus 2, which is 4. Okay, so we have an x-intercept of 4 and 0. And then we need to find the y-intercept. So y-intercept, we find this simply by making x equal to 0. So we'll say g of 0 equals 6 over, and in place of x, you say 0 plus 2 minus 1. So g of 0 is finally equal to, this is just going to be 6 over 2, which is 3. 3 minus 1 is 2. So the coordinates of our y-intercept are 0 and 2. So there we go. We have our intercepts, and now we can finally sketch this graph. So put down your Cartesian plane, and then you can start by putting down your asymptotes. So x is equal to -2 is the vertical asymptote. So it's a line down passing -2 on the x-axis. So there's -2. You can just write it like that, or you can actually write the equation. So x is equal to -2. As long as you show one of these, then they can see that that is that asymptote. And then the horizontal asymptote, which is y equals -1. And so we'll just draw a line passing -1 on the y-axis. Okay, so there we go. It passes -1. So y equals -1. And now we can put down our intercepts. So we have 4 and 0. So that is 4 and 0. And just, there's 2. So this would be 2, and then 4 would be around here. Okay, let's say here. So 4 and 0. And then we have a y-intercept of 0 and 2. So that is 0, okay, and then 2 units up. So there we go, passing 2. And now you also know the shape of your graph. You know that it's in the first and the third quadrant. So now just draw your graph. So you can see that this is going to come from being really close to the asymptote. It's going to pass the 2, move closer and closer, past the 4, and then just move closer to that asymptote, never touching it. Okay, so that's the first wing. And then the second wing, just draw it, kind of trying to copy the way this one looked. So like that, and move closer and closer to the asymptote, never touching it. And that is the graph of G. Moving on to the next question. Question 5.2 says, determine the equation of H, which is the line of symmetry of G, that has an angle of inclination of 135 degrees in the form of y is equal to. Okay, so they're not saying determine the equation of the line of symmetry with a positive gradient or a negative gradient. They're specifically just saying that it has an angle of inclination of 135 degrees. Okay, so you need to now figure out which one it would be, the one with the positive or the one with the negative gradient. Okay, let's just go ahead and deal with this step by step. If we have the graph of G, and they're saying that this particular line of symmetry, okay, remember how the lines of symmetry of your hyperbola look? They would always pass, okay, that intersection between your horizontal and vertical asymptote, and you have the one with a positive gradient, so going up like that, and the one with a negative gradient going down. So we need to figure out which one it is, positive gradient or negative gradient. Well, I can already see an angle of inclination of 135 degrees, which is an obtuse angle. The only type of line that creates an obtuse angle is a line with a negative gradient. But here's how you could have also seen this. So if it creates 135 degrees with the x-axis, okay, if you think about this is the x-axis and you measure 135 degrees, you would need like quadrants really. If you measure 135 degrees, you see that you're going to end up in the second quadrant, meaning there's your obtuse angle. Do you see what this line is doing? If you read it from left to right, this line is moving down. That's a decreasing function. Okay, so the gradient is negative there. But how would you find it? Well, to find the gradient itself, I actually just need that sketch here. To find the actual gradient, all you're saying is it creates a 135-degree angle with the x-axis. And so I need to find the gradient of this line. Well, to find the gradient of a line, when you have its angle of inclination, you say tan theta is equal to the gradient. So that will find the gradient. So the angle it creates with the x-axis is 135 degrees, and that would give you the gradient. So what's tan 135 degrees? You can use a calculator, but if you were simplifying this manually, you say tan 180 degrees minus 45 degrees, and then you see this is actually in sines quadrant, where tan is negative. So this would be negative tan 45 degrees, and so the gradient is simply -1. Okay, so there we got the gradient. And so they want us to determine the equation of this line. It has a gradient of -1. And what else do you know about this line of symmetry? This line of symmetry would also cut a particular point. And we just spoke about that. That is this point, okay, the intersection between your horizontal and vertical asymptote. So there we go. It would also intersect there. So its gradient is -1, and it passes this point, which is -2 and -1. That's the x and that's the y value. Okay, so we can find the equation of this line. Okay, you can use y equals mx plus c. The gradient is -1, so -1 or -x plus c. Then substitute this in place of x and y, and we have -1 is equal to negative, and then that's -2 plus c, and -1, and that's +2. If you take +2 over, it becomes negative. So -1 minus 2 gives you c. So c is equal to -3. And they want it in the form of y equals. So y is finally equal to -x minus 3. And that is our answer. Okay, moving on to the next question. Question 5.2 says, determine the value or values of x for which g of x is less than h of x. So g of x stands for the y values and h of x, the y values as well, of their respective graphs. So where do we have the graph of g? Let's just explain it as if there were straight lines. Let's say the graph of g was a line that looked like that, and the graph of h was a line that looked like that. If we were looking for the values of x, for which g of x is less than h of x, we're just asking, where are the y values of g lower than the y values of h? Okay, where are they less than them? So this would specifically be where the graph of g is below the graph of h. Because, for example, take this point over here. You see the y value of g? It's at negative value. Then for the same x value, look at the y value of h. It's this positive value. This is higher than this. So we're just looking for where the graph of g has lower values than the graph of h. In other words, where is g below h? Okay, let's see that on our graph. Okay, so that is h that we have here. This is the graph of h. Okay, so let's see, where would that be? If this is the graph of h and we're just trying to see g needs to be below h. So do you see this is the only place where g is below h? All through here, the graph of g is above h. You can look at it for a single point. So look at this point over here. Okay, this is its x value all through. So we're going to compare them, okay, compared to the same x value. This point has a y value over here. This point has a y value that's lower than that. Okay, the graph of g is above, unfortunately, the graph of h. We're trying to ensure that the graph of g is below the graph of h. It must be less than. So it is going to work all through here. You can use a ruler to also just see this. So if you took your ruler and you went through it, you would see that all through, okay, where we can see this graph, but it shoots up anyways. All through here, the graph of g always has a lower y value than the graph of h. Okay, see, the lower y value, and then we hit the asymptote, and then the graph of g goes above the graph of h. So you can highlight that wing and then just tell them that the values of x for which that wing exists. So it's all through here. And so if you line it up to the x-axis, you can understand that these are the x values. These are values that are simply, okay, look at where there's an asymptote. So these are all values that are less than -2, and that would be our answer. X is simply less than -2. So x is less than -2, and that is our answer. Moving on to the next question. Question 5.4 says, if the graph of G is shifted so that it coincides with the graph of P, then the question is, by how many units must the graph be shifted horizontally? Okay, so we need to look at the direction to understand this. So we're working with these two graphs, the graph of G and the graph of P. You see that we have the graph of G down. I know we have that, but we don't really need it that much. We'll just use a small sketch of it. So here are our two equations. I'll put that down. Okay, so this is what we have, and we can just go ahead and do this. With these graphs, right, we know what this one looks like already. One thing that is going to be very important would be those asymptotes. Because for it to coincide means it's going to lay flat on that other graph, okay? Or really just lie on it. So with this graph, remember that it had a vertical asymptote of -2, right? And a horizontal asymptote of -1. Now with this one, what would be the horizontal and vertical asymptote that we have here? With this one, the horizontal asymptote, as we can see, because this is x minus 3, okay, this is x minus p, the value of p is your horizontal asymptote. So with this one, the vertical asymptote, as you can see, it's x minus 3, so that's x minus p, okay? So it is an x value of 3, the vertical asymptote is x is equal to 3, and the horizontal asymptote is y equals 2, so y equals 2. For them to coincide, they would just lay flat on each other. So you can see that the value of A in both graphs is 6. You knew that this one looked like this. Okay, I didn't pause there. It looked like this, and then this part did this. So you can just focus on the asymptotes. So for it to move horizontally, okay, horizontal movements are left and right movements. They move horizontally, okay? So they said if the graph of G is shifted so that it coincides with P. So how must this be moved? Okay, if we're moving it left and right so that it matches perfectly with this one. Since the value of A is exactly the same, the only thing that is different is that vertical and horizontal asymptote. If this one was x is equal to 2, okay, and this is y is equal to -1, so horizontal movement would affect which asymptote? Now, I know you'll probably be thinking it's the horizontal asymptote. No, okay? If you move the horizontal line, it's just going to move in a straight line and it won't even look like it's moving. The asymptote we will move would be that vertical asymptote because this is the one that will be affected by a horizontal shift, okay? It's just a shift. It's describing the kind of shift. So if this was x is equal to -2, how must it move? How many units must it move so that it gets to this point of x is equal to 3? Well, it was at -2, so it must go 2 and then 3. So that's a total of 5 units to the right, and that's how it must be shifted. So we need to tell them that horizontal shift is going to be a 5 units to the right shift. So say 5 units to the right. And that is our answer there. Moving on to the next question. And the next question is just a continuation. So by how many units must the graph be shifted vertically? So a vertical shift, okay, we control that using the horizontal asymptote. So if this is the horizontal asymptote at y equals -1, how must it be shifted so that it lands here at y equals 2? So it was at -1, it goes 0, 1, 2, so it moves exactly 3 units up, and that is our answer. We'll just tell them it needs to be shifted 3 units up. Okay, so it seems like the kind of movements that they were referring to, right? They just mean that it's going to move one by one. Okay, so they will shift the graph horizontally and then vertically, and then it perfectly aligns with the graph of P. So we were just looking at that shift step by step. Okay, so that is it for this question, and that is it for question 5. Question 6.1 says, given h of x is equal to 3 times 2 raised to the power of x minus 6, 6.1.1 says, write down the equation of the asymptote of h. So this is an exponential function, and an exponential function only has one asymptote, specifically a horizontal asymptote. So it is in the form of y equals a multiplied by b raised to the power of x minus p plus q. And the value of q, that is your horizontal asymptote. Very similar to the hyperbola, it is also y is equal to whatever that q value is. So as you can see, the value of q here is -6. So the equation of Your asymptote is y equals -6, and that is our answer. Moving on to the next question. Question 6.1.2 says, determine the x-intercept of h. So x-intercept, to find the x-intercept, we simply make y equals 0. So this is h of x, that's y. We'll say 0 is equal to 3 multiplied by 2 raised to the power of x minus 6. And if you transpose this, it becomes positive 6 is equal to 3 times 2 raised to the power of x. To get to the x, we need to get rid of the 3. So divide both hand sides of the equation by 3. Therefore, 2 to the power of x is finally equal to 6 divided by 3 is 2. So to ensure that the equation is true, okay, the left is equal to the right, you have to equate the exponents since the bases are already the same. So x is finally equal to that exponent of 1. Okay, so this is our x-intercept. They didn't really say as a coordinate, so you can leave it like that. Moving on to the next question. The next question, 6.1.3, says, determine the y-intercept of h. Okay, so to find the y-intercept, you make x equal to 0. So instead of saying h of x, I'll just say h of 0 equals 3 multiplied by 2 raised to the power of 0 minus 6. Okay, so h of 0 equals, and we have anything to the power of 0 is 1. 1 times 3 is 3. 3 minus 6 is -3. Okay, so our y-intercept is y equals -3. Moving on to the next question. Question 6.1.4 says, determine for which the values of x will h of x be greater than 0. So h of x stands for the y values. Where will the y values of h be greater than 0? Okay, so we can think about what this, you don't have to think about what the whole graph looks like. You just need to look at specific things, look for specific things. So your graph is y equals 3 multiplied by 2 to the power of x minus 6. So certain values will tell you what your graph looks like. To find out whether your graph is above its asymptote, so we know where its asymptote is first. It's at -6, right? So it's y equals -6. This is the line, y equals -6. So to find out whether your graph lies above the asymptote or below the asymptote, we look at the following. So you look at the value of a. Okay, so the value in front of that number carrying the exponent. So you can see that a, or 3, is a positive value. So since it is positive, it means your graph lies above the asymptote. And that's really all you need to think about, because regardless of whether it is increasing or decreasing, that doesn't really affect all the values of x for which the y values are greater than 0. Now we just need to find out where the y values are greater than 0. You can just focus on where the y value is specifically equal to 0, then we will spot where it is greater than 0. So where is the y value on this graph specifically equal to 0? And we just worked on a question that asked for this. Well, indirectly asked for this. This is at the x-intercept. Okay, to find the x-intercept, you make y equal to 0. So what was the x value that we got there for our x-intercept? It was 1. So what this means is, regardless of what this graph looks like, okay, I actually luckily drew it kind of accurately. Okay, let's say it was somewhere here, right? And we know that regardless of what it looks like, I don't know if it looks like the blue or the, we can actually discuss that. To find out whether it's increasing or decreasing, just focus on these two values together, okay? So it's very simple. All you have to do is think about two x values that come right after each other. You can try x is equal to 1 and x is equal to 2. When you substitute 1 in here, what is the y value you get? If you substitute 1, that is 2 to the power of 1, which is 2. 3 times 2 is 6. If you substitute 2, that's 2 squared, which is 4, times 3 is 12. And then just look at what your graph did. From x is equal to 1 to x is equal to 2, what did the y values do? Did they increase or decrease? They increased. So this means that your graph is an increasing function. So it's a blue one. That will probably help for any other question that they have on this. And so you know that it passes 1 on the x-axis. So this is where its y value is equal to 0. The question is, where is the y values? Where will the y values be greater than 0? So you see, this is where y is equal to 0. And then look at these values over here. What are the y values here? The y values here, if you map them to the y-axis, these are all y values that are greater than 0. okay, because this is where y is equal to 0. And then these ones below the x-axis are where your y values are less than 0. So you can see where the y values are greater than 0. If you line this down to the x-axis, you can see that this is where x is simply greater than 1, okay? Numbers to the right-hand side of 1. So that would be our answer. We just tell them this is where x is greater than 1. Moving on to the next question. Okay, question 6.2 says, draw a neat sketch of the graph of g of x, a new graph. Okay, but it's also an exponential function. And they tell us the following. A is equal to 1. Remember what happens when a is a positive or negative number. If it's positive, okay, wherever its asymptote is, it lies above the asymptote. Doesn't matter whether it's increasing or decreasing, it's above the asymptote. When a is negative, it's below the asymptote, okay? It could be increasing or decreasing, but it just lies below. So in this case, we know that this graph lies above its asymptote. And then they tell us the value of b. B is a value greater than 0, but less than 1. There's a word that we use for numbers like this, okay? Values that, well, if it's positive, it can also be negative as well. But these are values that they're fractional numbers, right? But they don't pass 1, okay? And they're also just not less than 0. This is where you have a fraction where the numerator is smaller than the denominator. This is a proper fraction. So you're going to have this kind of fraction, for example, like 1 over 2 or 3 over 4, okay, where the numerator is always less than the denominator. And we'll just see what exactly that causes the graph to do. Lastly, they also tell us the value of q. Okay, it is -1. So we can start sketching. We'll speak about what to really look forward to. You see how the previous question really helps us to see what we need to do here. The previous question would help you know how to draw your graph. Okay, you know how to determine whether it's above or below the asymptote and whether it's increasing or decreasing. Okay, so here's the thing about this. We'll just put down our Cartesian plane first. And let's just put down this that we know. We know that the asymptote is y equals -1 because that's the value of q. So y is equal to -1. We'll put that down. Y equals -1, it's a dotted line. We also know that the graph lies above the asymptote. So it's going to be all through in the first and the second quadrant. Now we just have to figure out whether it's increasing or decreasing. So looking at that value of b, b is a proper fraction where the numerator is less than the denominator. What happens with numbers like that? You see, you have to say a multiplied by, and then you're going to say that proper fraction, and you're raising it to an exponent. We can just monitor what is going on here. We know that a is 1. Okay, so monitor what happens to this. At least it's multiplying to a value of 1, it just stays the same. So if you try x is equal to 1 and x is equal to 2, look at what happens. You see, you're going to raise it to the power of 1, the y value would be a half. When you raise it to the power of 2, the y value will be 1 over 4. What did your graph do? From this point to this point, did it increase or decrease? It would have decreased because we know that a quarter is less than a half. So that's what happens when that value of b is greater than 0 but less than 1. When it's a proper fraction, what happens is the denominator grows bigger than the numerator or grows faster than the numerator. And so it makes the fraction just get smaller, okay? Because when the denominator is bigger than the numerator, you're going to get a small fraction, okay? And if it continues growing like that, your values keep decreasing. So we know now it lies above the asymptote, and we also know that it is a decreasing function. Let's try to find the x and y intercept. So if we were trying to find the y-intercept, we would simply make x equal to 0. And we can because you see, even if this is b, we know what a is. And, anything to the power of 0 is 1. So if you had g of x and you say this is 1 times b raised to the power of x and then -1. Okay, this is what it looks like right now. So find the y-intercept, you make x equal to 0. So g of 0 equals 1 times b raised to the power of 0 minus 1. Anything to the power of 0 is 1. Okay, this multiplying just becomes 1. 1 minus 1 is 0. Okay, so in this case, we have 0 and 0. So this is both a y-intercept and an x-intercept. Okay, x-intercept is where y is equal to 0. Y-intercept is where x is equal to 0. So it's both. So this would be a graph that passes the origin, and it's specifically, you saw from that info that we did where we were looking at whether it's increasing or decreasing, this is specifically a decreasing function. So our exponential function looks something like that, moves closer and closer to that asymptote, never touching it. And this is the graph of G. Okay, so they would want to see all those points. So that is it for this question 6.2, and that is it for question 6. So that is the last question for this paper. Okay, and I hope you guys enjoyed it. Please make sure to leave comments if you do have questions. And I hope to see you in paper 2.